Hello there, I'm Dr. David Riley, and we'll be continuing these online lectures in survey design by looking at the issue of sampling error and sample bias. They're two very important issues you need to consider when interpreting existing psychological research, but even more crucially when you're conducting surveys yourself. So we all know the difference between a descriptive statistic, like the mean standard deviation, and an inferential statistic, like the t-test. Is there a difference between two groups? Is there a correlation between two psychological constructs? So we often use sample data to make inferences about the underlying population. So, for example, if we wanted to avoid having to measure the height of every Griffith student, we could just look at a sample of the students in this class, and all things being equal, it would be the best estimate of the underlying population, so the height of all Griffith students. But samples may fail to provide good estimates of the population for two reasons. One is sampling error. So you just purely use dumb luck. You happen to sample the wrong participants and you got either an inflated score or a deflated score. The other is sampling bias, and we'll be covering both of these issues. So you probably heard just a little bit about sampling error in your early statistics classes, and then just filed it away and forgot about it. But no matter how careful we are, no two samples from the same population will be identical. By chance, there will be natural variation in scores, and we call this sampling error. If I took a random sample of 50 students from Griffith University, it would be a complete fluke if the mean for that sample was exactly the population mean. Now, the term sampling error implies a mistake, but this is actually misleading. It's a natural thing that can't be helped, but that we should take into consideration. The question is not whether the sample mean differs from the population mean. It almost always will, but how likely is it the difference between what we observed could have occurred by chance? And that's where we have inferential statistics and null hypothesis testing. Now, a statistical inference is the foundation of hypothesis testing. We use sample data to make inferences about population parameters. This allows the researcher to determine the probability that the sample is from one population and not another, that this is a clinical sample and not a general community sample. We're actually not really interested in the characteristics of the sample. We're interested in the characteristics of the underlying population. And it enables the researcher to evaluate the support for a hypothesis as if a whole population was available instead of just a small but hopefully representative sample. Okay, so sampling error is probably the easiest aspect of the research process to consider, but it involves a refresher on statistics. Now, if you're like Eddie over here, you might be apprehensive. I promise you there won't be lots of formulas. It won't be heavy going. So, sampling error controls our precision. If we repeat the sampling process an infinite amount of times, would the standard deviation of the estimates be big or small? Well, that all depends on our sampling size. If we want precision, then we want a smaller standard deviation. And if we want precision, we're going to need a larger sample size. The smaller the standard deviation, the greater statistical power, and the more likely you are to have data that's going to be happy for your supervisor and it's going to be happy for you because you can publish it. So most students with a statistical background understand intuitively the average or the mean. but they really struggle with this concept of variability and sampling error. So if we were to repeat the process of sampling ad infinitum and we were to graph the distribution of scores, then we would find that it approximates this normal distribution, which I showed you earlier. But what if I only do it once? Well, that's the danger, because in a survey, you're generally only doing it once. And so your score for your mean might be somewhere in the middle, 68% of the time, but it might be greatly inflated, or it might be significantly diminished. And it could be any of those scenarios. So it could start down here or move all the way up to there. And that's the danger, I think, of sampling error, because the conclusions that you draw may not be replicatable to another researcher. It may not be generalizable to the underlying population. So central limits theorem suggests that if you have a sufficiently large sample size, n is equal to 30, then even if your underlying population is skewed, it will approximate the normal distribution when a simple random sample is used. But how many studies in your field, now think carefully, how many of you read that employ a simple random sample for the population for a survey, instead using a convenience sample? So when you're employing a non-probability sample, like clinical, like the employees of an organisation, then central limits theorem does not apply. And you will need a much larger sample size than your statistical power estimate will suggest. So if you're going to opt for a convenience sample, go for a much larger sample size. Otherwise, your sampling error is going to be huge and you will reach erroneous conclusions. And the literature is littered with these types of studies. Now, just to illustrate the concept of sampling error, I'm going to steal an example here from Andy Field. Andy has a very sort of nice, simple, conversational way of illustrating these concepts. And rather than reinvent the wheel, I'm going to steal from him. Okay, so I want you to imagine that I'm a lecturer and each week I'm recruiting a small sample of participants, so 4, and I'm going to get them to fill out a Likert scale from maybe 1 to 5 based on how much they enjoyed the lecture. And you can see, I'll just turn on my little pointer here, that there's a mixture of, neutral, happy, neutral. We've also got some sad people. Look, this one's even crying. They hate my lectures. So the underlying population, the mean, will be 3. So a midpoint, they neither liked nor disliked. But individual samples are going to differ. So if I were to select this sample here, in this case purely by chance, it happens to equal the population mean. But if I were to sample this one here, I've got more sad people, so they score somewhere down here. They don't like my lectures. For some reason I rubbed them the wrong way, they didn't like the humour, or they just thought stats was boring. Okay, now I sample again, and I get all happy people. I like this group. I wish all groups were like that, so they give me a score of 5. So you can see that the sampling error can vary across samples. And so if you have a really small sample size, you're going to have a large degree of sampling error. And central limits theorem would suggest you need 30, but of course that's for a simple random sample. And I'm pretty sure there'll be a lot of people here either recruiting from businesses, organisations, or from clinical samples, in which case it is not a probabilistic sample, and you can't rely on central limits theorem to save you. You need a sufficiently large sample size. Okay, but you can see there on average across all the sampling, that's the modal score that we get. Alright, okay, so the sampling distribution can apply to any statistic. The most common is the sampling distribution of the mean. What's this all mean for surveys, huh? I didn't sign on for a stats course. Well, it means that if you're intending on administering a survey, you need to pay great attention to the sampling method and, to a lesser extent, the sampling size to ensure that your conclusions are solid. But I'm a psych. I don't need to worry about this, right? Well, even if you're not conducting research for a survey, you will be evaluating the results and the analyses of survey in the literature. So I can see why you might think you don't need to pay attention to it, but it's actually wrong. You will need to understand these concepts. So in most cases, you'll instead be acting as the psychological consumer of research, not the producer. Each time you read a journal article, you need to be able to evaluate the evidence objectively. This is one of your ethical obligations, that you need to critically analyse the scientific literature and to use evidence-based practice. And one of the things you need to include in your considerations is sampling error. How likely is it to generalise to other samples? And the issue of sampling bias. Was it a non-representative sample? So you might have learned that your test of statistical significance, p less than 0.05, means that there's only a 5% chance of falsely rejecting the null hypothesis. Unfortunately, it only applies when you're doing a simple random sample that is representative of the population. Rarely do we encounter this. So, you might have heard that... Oh, crap. So, you may have heard about the reproducibility crisis and the argument that most psychological research is prone to selection bias. So here is some headlines taken from the news. It was based on a high-profile study done in Science, one of the most prestigious scientific and academic journals, and it was specifically about psychology research. They attempted to replicate 100 experimental findings, and over half of the studies failed to replicate. Now, I would suggest that it would be very, very rare for people to engage in data fabrication. It would be very, very rare for an experiment not to be conducted, with good clinical oversight, with really good experimental control. But what is more common is that the samples that they recruit are predominantly subject pools or they're convenience samples. So selection bias in surveys could be the single most important thing you take away from this online lecture. Your null hypothesis significant testing only holds for randomly selected probabilistic samples. Who does that, right? So as a practitioner, you need to be rightly skeptical of whether the findings you read about will generalise to your patient or your client base. So sampling bias is probably the single most serious threat undermining the credibility of psychological research. Who you ask makes all the difference. So I'm going to present a range of examples, and I'm going to try to avoid drawing too heavily on either the clinical psychology domain or the organisational psychology domain, simply because I don't want, you two groups getting jealous. But rather than insult your intelligence, I'm going to assume that you're familiar with basic survey concepts like the sampling frame that outlines your target population. So let's consider the classical case of a self-selection bias. When offered the opportunity to take a medical drug, see, it's not clinical, it's psychiatric, like an antidepressant, over the choice of a psychological intervention. There will be basic differences between these groups before they've even had the intervention. Different expectations and beliefs about efficacy, different levels of motivation. Maybe I want to get it over real quick or have the problem solved, so I think I might take the drug instead. There might be different levels of severity of the condition too. People who want to pursue medication, maybe they're more deeply depressed, and so they really want something they know will work. So because the two groups differ pre-treatment, we lose experimental control and internal validity. We can't argue cause and effect. So by this point, the mere mention of a clinical example, and I might just have lost the org psych guys. So bear with me, guys and gals, we will be getting to an org psych one. Now, when you recruit subjects from a university subject pool, you're actually introducing a self-selection bias. They choose whether to participate or not. Increasingly, a large number of students are conscientious objectors and they use the alternate assessment tasks, or they choose to do the study that sounds more fun or more cool, or that sounds like it'll be a little bit easier. Now for the org psych. When you ask busy, stressed and overworking employees in an organisation to take yet another rassing survey, you're introducing self-selection bias. So it's very rare that we actually have a random sampling here, because people choose to participate. And I'm going to leave aside the ethical issues of when there is compulsory participation. But the ones that volunteer are going to be less stressed, more motivated, more conscientious, etc., than the ones that decline to participate. So well-conducted survey research and sampling takes this into consideration. Now, if the experiment or study is unlikely to be affected by the self-selection effect, you're fine. But if accepting the evidence of a study is important, or of a psychological intervention delivered to the community, if it's actually going to be perhaps used or considered by, governments or public health campaigns, or a business, or an organisation, then you have to do your homework before you do that survey and check whether there are any known moderators like conscientiousness, stress, employee motivation. And well-conducted research will co-measure these on the survey to at least describe the characteristics of a sample. So if it doesn't use probabilistic sampling and it doesn't co-measure known moderators, caveat emptor, the buyer beware. Statistically, it's very easy to throw these into a regression, and it might only take, an extra 5 minutes to add some of these measures in, and then you can either control for it, or you could perhaps even report, and this will give you an extra line of analysis, report the effect of those moderators. Another issue to pay attention to is the issue of referral bias. Now, this one will be more of a clinical issue. But I'm going to select an example from educational psychology, again, because I don't want any rivalries between the org psych folks and the clinical folks. Okay, so consider the example of dyslexia or reading impairment, which is a subclinical level. So it's I'm going to have to wait just a moment for that to go away. So one other issue with sampling you need to be aware of is the issue of referral bias. So I'm going to select some examples from educational psychology so as not to favour org or clinical psychs. But, referral bias you'll often encounter in a clinical setting because there will be certain types of people that you will be referred on to your clinic. Certain types of people won't. If you're working in an organisational setting, there will be certain types of people who become known to HR and certain types of people who don't. So consider the example of dyslexia or reading impairment. So this is a level of reading impairment at a subclinical level that wouldn't meet the threshold for a formal diagnosis of dyslexia, and these types of students often creep through. Now, the condition is more commonly observed in boys, so parents and teachers are vigilant for any difficulties and are more likely to refer these boys on for diagnostic assessment. So surveys using parental and teacher informant reports suggest that boys are 3 to 4 times more likely to be labelled as reading impaired. But an epidemiological study, which is one that actually does a representative sample, finds a more modest gender difference, suggesting that it's actually underdiagnosed dyslexia in girls. So this illustrates, again, referral bias and the effect of sampling. So if you just went to a school and asked them for the people who were reading impaired, you're probably more likely to get boys in that sample and less likely to actually detect the girls, unless you measured everyone. So with survey design, we typically sacrifice our internal validity, watching the participants as they're filling it out, because we lack the same level of experimental control and we're not assigning people to groups generally than we would have in a laboratory situation or a clinic where it's supervised. That's why we have to pay greater attention in survey research to issues of external validity and generalizability. This is even more crucial when there are known moderators like age, gender, socioeconomic status, personality traits. So heaven help the researcher or practitioner who relies solely on student subject samples. In my own research, looking and measuring at responses of the subject pool, and also just from dealing with alternate or deferred assessment applications, mental health issues are running at least twice the prevalence of the general population in our subject pools. Maybe it's a property of being a university student, or maybe it attracts a certain type of person to psychology. So much better evidence on general psychological phenomena can be obtained by a community sample, where we're not going to be susceptible to this sampling bias. So if randomly selected or stratified sampling, we should be reasonably confident that it's representative in terms of socioeconomic status, mental health, personality traits, age, etc. But your sampling method, the telephone, the personal contacts, the online, and the sampling frame can skew these pretty considerably. So good surveys actually measure them. They measure those demographic traits. Another thing that is particularly important when you have a higher threshold of evidence is using nationally representative samples. Even stronger evidence can be obtained from a nationally representative sample than a local community sample. Becker and Hedges caution that selection and variability of the sample can yield drastically different conclusions. Even at the suburb level, there are dramatic differences, which is why it's particularly important for political polling. At the state level, we can still see dramatic changes between rural and urban, for example. Now I'm going to illustrate this with a cautionary tale on sampling and why nationally representative sampling is a much higher threshold of evidence. Now this may not apply to the surveys you administer unless you have access to a big research budget, but you again will be reading about nationally representative samples, and you'll also be reading about convenience samples. And when the two studies differ, you'll need to make an interpretation. So I'm drawing here from educational psychology. Hyde et al. 2008 examined state data from 13 American states on mathematics testing, and they published this data in a widely reported science article that argued that there were no gender differences present. So all of the educational interventions that we had invested significant resources into, and we'd actually gone and tried to make it evidence-based and build up the literature to suggest that it really works, all of their funding got cut. Now, this study actually lingered unchallenged for a considerable length of time. But it stood on the publication record for a decade until the nationally available datasets were made publicly available. And I and several other Griffith lecturers were able to actually analyse that data. And we found that there were actually some pretty substantial gender differences still present. Now, the local state data, it was a little bit iffy for a whole variety of reasons. But the national data set showed these pronounced gender differences. And we were able to refute the assertion that, we don't need to fund girls' education in mathematics. We don't need to raise the profile of girls in science and technology, engineering and mathematics. But it's a good cautionary tale on how where you look and who you ask determines the conclusions that you drew. We drew two very different sets of conclusions. So sampling bias will affect the validity of your conclusions. It will also affect whether people will accept your conclusions, whether your research will get published. So I've mentioned the dangers of self-selection bias earlier, and if you're an organisational psychologist, this may be particularly relevant. So employees are generally encouraged to participate, and if it's truly voluntary, you're going to find differences between participants and the conscientious objectors. But in some organisations, employees are coerced to participate in subtle and not so subtle ways. So they might get a follow-up email that lets the employee know that they've yet to answer. Straight away, if I got one of those, I'd be thinking, this isn't anonymous anymore. They know I've filled it out or that I haven't. So that's going to affect the honesty of my answers. There may be a participation quota or targets. Whole organisations, maybe branches might be reprimanded because they didn't fill out the survey. So again, this takes away that cloak of anonymity and affects the conclusions drawn. Or managers hinting at the types of responses that they'd like. Now, while they always say in the email, we encourage you to be open and honest about your issues, they don't really want to get too many complaints. I'm going to give you a couple of other examples of sampling bias. This is taken from the political arena. We often talk about this in statistics with undergrads. We talk about a classic example of telephone polling in 1948 for the presidential elections. Dewey, a Republican, was predicted to win by a landslide. But Harry S. Truman, who earned the popular vote, he won easily. Why? Well, in 1948, only the rich people, very conservative, had telephones. So by only asking the conservatives who would they vote, they reached a very different conclusion. So it's a good illustration of why random sampling is really important. So if there's some limitation, like access to a computer or a laptop, if you're dealing with elderly populations, then that's going to potentially affect the validity of your conclusions. Random sampling, ideally every member of a target population should be equally likely to be selected for the sample. Now, I bet you're probably thinking, I wasn't even born in 1948. What am I doing talking to you about an old political survey? So let's consider something more relevant. So, probably none of us were born in 1948, but we do remember the election of Trump. All the interview polls, the surveys, even door knocking, so it wasn't just a telephone thing, had Hillary Clinton set to win in a landslide popular vote. Now, if we put aside issues of the Electoral College, a major factor was telephone polling. Again, use of landlines. A lot of people didn't have landlines. They'd gone to mobile, so the younger demographic didn't get polled as much. And there was also some sampling bias there. I suspect as well, and this is one of the arguments that's been made, there was social desirability bias at play. But we've covered that in the previous lecture. So social desirability, people didn't want to admit to voting for Trump. So I'm going to leave you with a reading on, I don't actually intend you to actually read it. I just want you to have a look at the argument made by Hedges, who's one of the world's leading statisticians and also one of the leading survey researchers. That the two greatest advances in statistical generalization, so external validity, was the development of randomized experiments, which we all know about, and probability sampling. Randomization provides protection against the effect of the treatment and potentially contaminating variables like self-selection. But probability sampling permits unbiased estimates of population parameters that do not depend on modelling assumptions like normality, thus ensuring one more important element of external validity. So the purpose of experiments, and I would also add to this surveys, is to obtain information that can inform public policy choices in education, medicine, the social sciences, and businesses. Yet experiments and surveys with probability samples are very rare in these fields. So, if at all possible, consider trying to shy away from a convenient sample going for a randomized sample. If you can't, then at least measure the known moderators or the ones that theoretically, you might suspect would alter the outcome. Because if you do that, then you can strengthen the validity of your conclusions, you'll strengthen the external validity, and if you want the prestige of being published, you're more likely to get it past peer review.